easy for you with your Beats by Dr. Dre and your iPads and your...
Oh no, for me it's kind of different. You buy something new when it breaks. I just continue using it.
Oh, nice, nice. How does that happen? You drop it?
Yeah.
Water? What was it?
No, I was just trying to switch off the alarm.
You were trying to switch off the alarm and you did that to the screen?
Yeah.
Nice. You like pounded it or something? Ah.
No, it fell off.
Oh, right, okay. More sleep. Damn. Right, so what's the information given in the first one then?
Car is traveling at 80 kilometers per hour.
Right, so we'll have to convert 80 kilometers into meters per second. Were you able to do that?
Yeah.
What did you get?
33.3 meters per second.
Yeah? No.
No, wait, it was
22, that's better, yeah.
22,
22.2 meters per second.
Yeah.
So that's the U, is it?
That's the U.
Yeah, and then what happens?
And the driver puts her foot down,
We did one like it, yeah.
and the car accelerates to 120 kilometers per hour.
So 100...
That's 33.
That's 33.3, yeah. And over a distance of...
300 meters.
Right. And you want to know...
Acceleration, how long did the acceleration take, and how large was the acceleration?
So in other words, the A and the T then,
Yeah.
So we'll go with B squared equals U squared plus 2AS. 33.3 squared equals 22.2 squared plus 200 A. So what I'm doing first is I'm getting the A. Okay? So hopefully...
Can't you get the T first?
Yeah, whichever you prefer. Doesn't matter. So hopefully I should get the same answer as you. Did you get 3.08 for the A?
I got 1.03.
No. What did you get for the A? No, hang on. 33.3 squared minus 22.2 squared divided by 200. Yeah, 3.08 is what I got for the A. What did you get?
1.05. I think that we found the T first, and then I think we substituted the T.
Should be the same answer though.
It should be.
Oh no, sorry, my mistake. I did 100 meters. It's 300 meters. So 2S would be
Yeah, probably.
600 here. So I'll fix that now. So you should have gotten 1.03. Yeah, great. So the A is 1.03 meters per second squared. And then let's get the T. What formula? I'll go with V equals U plus AT.
Yeah.
So we get 33.3 equals 22.2 plus 1.03 T.
We should use the basic one.
Yeah, that too, whatever you prefer. So did you get something like 10.8?
Yeah.
Great, 10.8 seconds. They're the two answers for number one. Okay, number two now. Just make sure your answers are right. Okay, can I scroll down? Number two. Right, so what's happening in number two now?
A cyclist starts cycling from rest at acceleration 5 meters per second squared.
Yep.
And how long did he cycle? How long until he cycled 100 meters? And how fast is he cycling after 100?
So again, what's the V and the T then? So what will we go with? V equals U plus 18. No, V squared equals U squared plus 2AS, maybe. V squared equals U squared plus 2AS. So V squared equals 0 plus 2 times 5 times 100. So V squared equals 1,000. So V is square root 1,000. Yep. So V is, the answer is 31.6 meters per second. And then T will be V equals U plus AT. 31.6 equals 0 plus 5 times T. So just this answer divided by 5, and we get T is 6.32 seconds. And that's the answer for that one. So again, not too difficult to do. Okay. Now, on to number 3. Okay, so what's happening in number 3?
A ball is thrown vertically upwards with a velocity of 40 meters per second. How long until it hits the ground?
So it goes up and comes back down. So this one is a little bit tricky, but we'll see what we do. So the U is what? 40. The V we don't know. The A we do know. What's the A? The T we don't know, but the S we do know.
0.
Yeah. Why?
Because it goes back to the same position.
Yeah, it's back at the ground level again.
But then isn't V 0 since final velocity is 0?
No.
The velocity just before it hits the ground is not 0. So V's only 0 up here.
Or take half the way up and V is 0. And that's half T.
That's what it is.
Yeah, I suppose.
Okay, yeah,
Yeah, no, I don't like it. Right, so we have S equals UT plus a half AT squared. 0 equals 40T. And then a half A is 4.905, isn't it? Yeah. Minus 4.905 T squared.
Yes.
We can factorize.
Yes.
Oh, I know
did
this. Yeah.
And I didn't get any answer.
What do you mean?
Then I did with the half the way.
So we have either T equals 0 or 40 minus 4.905 T equals 0. Because we have two possibilities here, like what we did in maths class today. So then T will equal 40 divided by that, 8.15.
That's correct. 1/6.
It's
Yeah.
negative 8.
But then time can't be negative.
No, this one's a positive.
It's a positive. It was a negative.
Okay.
But we can do the like halfway.
But I don't like it. You can. I mean, if you like doing extra work unnecessarily, no problem. But I personally don't. So I try to do things the quickest way possible. And trust me, this is the quickest way.
Is it acceptable in the test?
It is acceptable in the test, yes. Okay, on to 4 now. Right, what's happening in 4?
A person walking at 3 meters per second starts running at reaches
Yeah,
10 meters per second
Yeah.
over a distance of 50 meters.
yeah.
What was their acceleration? How
And
long
time,
did it
yeah.
take?
So, same old story, V equals U squared plus 2AS. 100 equals 9 plus 100A. So, what's that? 0.91 is the A. So, the A is 0.91 meters per second squared. Did you get that? Or maybe I did it wrong in my...
I got 0.91.
Yeah. Okay. And then the T is V equals U plus AT. 10 equals 3 plus 0.91 T. 7 equals 0.91 T. So T equals 7 divided by 0.91. 7.69?
Yeah, 7.7.
Yeah. So the time is 7.69 seconds. So that's number 4. Now, how many questions did I give you? 5, 6? 5. So the last one was tricky, wasn't it? Okay, time for 5? Right. Go for it. Number 5, what's happening?
Two cars are 300 meters apart.
Okay, so let me just draw this. This, firstly, is 300 meters apart. Right.
They're in opposite lanes.
Okay, so there's a car here, and there's a car here. Okay.
They're traveling towards each other,
Yeah.
and they each start at rest and have accelerations of 10 meters per second squared.
Okay, so they each start at rest, and then the accelerations are, yeah,
10 meters per second squared and 15 meters per second squared.
10 meters and 15?
Yeah.
Okay,
How long until they pass each other?
great, so when do they meet? So, where do you think they'll meet? In the middle, somewhere to the left, or somewhere to the right?
Left.
In the middle.
I was just waiting until I heard all 3 answers, so thank you. So, do we have a final answer, left, middle, or right?
Left, because the right.
Yeah. Left is correct. You have to think carefully about that. Because this is going faster, or rather it's accelerating more, it will get to here before this one can get to here. So the crash should be somewhere
They don't
like here.
crash.
Well, they don't crash. No. I changed the story so they
the
don't
V is
crash.
not zero. That was the annoying part.
Well, even if it did crash, the V wouldn't be 0 because it's the velocity right before impact.
Okay, no.
Yeah. Anyway, it's UVATS, but let's look at the complications. So, let's look at this car. UVATS. What's the U?
Zero.
0. The V we don't know. The A, 10. The T we don't know. And the S we don't know. Here, UVATS. Now, just before you say anything, in the left picture, I'm taking this as the origin. And this is negative and this is positive. Okay? But on the right picture, I'm going to take this one as the positive and this one as the negative, and it's starting here. Okay. So, in the picture on the right, what's the U? 0. V, we don't know. A, 15. T, we don't know. And S, we don't know. Bit of a problem, because remember, what did I say? How much do you need to know? 3. Okay, so, did anyone get this?
Yeah, I did.
What was the distance?
No, I got the time. No, the distance was.
Did I ask for when or where do they meet? When? The time,
Yeah,
okay.
The distance is 180 from the left side, 120 from the left side, and 180 from the.
Did you get the time? Well, then you can get the
The
time.
time is 24.
So what was the trick then for this?
Simultaneous equations.
Yes, but how can you make simultaneous?
You know that the distance that A travels
Yeah,
plus the distance that B
that's it,
travels
good,
is
yeah.
300.
So the
And
trick,
the T is equal for
and the
both.
T's have to be equal, that's it. So the trick here is, okay, you don't know where they meet. So you say, well, the first car will say that travels S1. So we'll call this one S1. And the second car will say that travels S2. And we don't know what S2 is. But we do know that they meet at the same time, and critically, S1 plus S2 must equal 300. And this is the key to solving this. You don't know how far they each travel, but you know in total they travel 300. So, formula for S1. S is equal to UT plus a half AT squared. So here it'd be UT plus a half A T squared. Plus, and now S2, what's that going to be? 0
plus
T plus
10, 15, 15.
No,
7.5.
7.5 T squared
Yeah,
equals
300.
300. So this is the S1 and this is the S2 using the formula UT plus a half AT squared. That's the formula for S. So 0, 0, together that's 12.5 T squared equals 300. Yes? Take that down and then square root, and we have our answer. Square root 300 over 12.5, which comes in at 4.9 seconds. That's when they meet. After how long? So this one was a hard one for sure.
Find S.
Good practice though.
Find S.
Does it ask for S?
No, but because my T is different.
Oh, a half a t squared. So the first S, the smaller S here I got was 60 meters, and then the other one it should be 240.
Don't think it will be two.
No,
Maybe is it 240?
it is not. So 300. Sorry.
I tell you.
No, don't tell me. I want to find it myself. No, it's not 60. I mistyped it here. It's 120.
Yes.
I just typed it in wrong on the calculator. And the other one came out at, let me double check it.
180.
It came out at 180. Together, that does make 300. Yeah, so this is right there. Yeah, so that one was hard. For sure that one was hard.
My T is not the same, but I have the distance the same.
That shouldn't work.
Yeah, but it's
What T did you get?
24.
I got 24 too.
But you got the distances right. Well, did you set the diagram up the same way as me?
The diagram?
Yeah, like the way you considered the system. You know the way I said positive and positive.
How does that work?
Yeah.
I'm trying to think for a reason why your T is different. It shouldn't be different.
But my S is the same.
Yeah, but your
So
T
how
shouldn't.
can-
Yeah, I don't know how. Show me what you did and I'll tell you how. It almost sounds like maybe there were two mistakes, and by luck you got to the right answer.
Maybe you
We'll
can-
see.
My luck.
No, I don't think so.
Is it 18? Like the
No, 0 T.
No, okay, I know my mistake.
Yeah, what's your mistake?
Yeah, the square.
You've got the squares here, but because you forgot the squares in this formula as well, this is the mistake that cancels the earlier mistake. Yeah.
I know, I did this.
I told you it was by luck. Right. Okay, can I close this now? Did you write it down? Yeah. Yes?
Yeah.
Okay.
So